Tambah. Apa boleh? Iya kan? Makanya.
Yeah, no worries. I'm not going to close the door whatsoever. Even if you notice for this Zoom session, I don't. If you experience with Zoom before, normally the Zoom will put you in a kind of waiting room, then waiting for my approval for you to get into the room. But for this one, I said so that you can get into the room straight away. So it means that I'm not locking the door. Yeah, I can if I want to. But yeah, I understood this is come on, this is online. Yeah, you don't have to be as straight as a normal face-to-face sessions. So we're still waiting for the rest. The number is increasing, 19 now at the moment participants. Well, how many students we have in this course supposed to be? Just give me a second. Supply maintenance. We supposed to have 28 students. So 29 participants of Zoom channel, including myself. Okay, before forgotten, please make sure you record your attendance for today attendance in our Putra Blast. Some of you might forgotten yesterday, I noticed. Please do so now. I give you time. Yeah. Because even though this is online, the it's university requirement, we still tracking your attendance. So how many attendance now? 20. Okay, not bad. We wait for another, how long? Another 2 minutes, 3 minutes, then we start. Okay. Last time during face-to-face sessions, the what I call standard waiting time is 10 minutes. Is it? Sorry, 15 minutes, isn't it? Yeah. Oh, I'm forgotten to record. Just give me a second. I think I can start recording now. Okay, I just switch on the recording. So we are now on the recording. Okay. So shall we start? So how many attendance now? 20. Are they increasing?
Assalamualaikum. Good morning.
Yes, good morning. I wonder, can you hear the surrounding sounds from me now? Little bit. Yeah. Is that disturbing? No. Okay, good. Because I think I'm using this mic. It's supposed to be filtered. Okay. It's still 20. Okay, never mind. We just proceed. Okay. Good morning, everyone. So, during the last class, I give you a bit of a hint of the importance of software maintenance, and basic definition of software maintenance and how important it is in software development industry. So today we're going to continue the same theme. Okay, but we go more on detail on details more on the definition, on the some misconceptual misunderstanding about software maintenance. Okay, before we go further, yeah, let me share you my screen. Okay. Okay, perhaps you can see my screen here, and I already uploaded this to our Putra Blast. Okay, for those who, before we start, a reminder, please make sure you record your attendance in our Putra Blast system. Some of your, I noticed that you forgotten to record your attendance yesterday, not yesterday, the other day. Okay, we start with this chapter 1, introductions. Okay, during our first session, it was my own introduction. This one is taken from one of our textbook. Okay, so for this chapter, okay, yeah, this one is again the this course objective. Okay, I think this has been covered in our last session. And look, okay, the context of maintenance. Okay, the study of maintenance begin with when we're trying to understand software change. Okay, regarding software change or request of change is happens, okay, the very moment when we install our software to client, request for change. But then, as I said before, since our product is intangible, yeah, it's nothing to it's hard to see, it's hard to, what do you call, hard to touch. This change supposed to be properly managed, because if we fail to manage the change, we end up with unfinished entertaining or forever entertaining request of change. Yeah, you understand me, is it? Because users normally, whenever we started to install the software, they started to request this and that. That is normal, because in the beginning, as I said before, the nature of our industry, users normally don't really understand about what actually they need. They don't really understand the requirement. So normally even though we have a specific process on getting the requirement, this and that, and finally we have first versions. But after the first version installed, they started to request for change. Now, why the request for change? One, of course, because of some problems. If there are some lacking of the system, some problem of the system, and it would be new ideas, it will be new adaptations. So we have to further study this change, and the study of this change, okay, become the fundamental of software maintenance. Okay, so so this change somehow, as I said just now, we have to put some limitations, some constraints on entertaining this change, and of course there are some theory. So basically all of this that we're going to discuss today, okay, that covering this fundamental of software change, VG-based concept, maintenance framework, software change fundamental, limitations and economic implication, maintenance process model overall. Okay, so we have for only about 1 hour today. Yeah. Okay, now first thing, maintenance is always misunderstood. I think it is normal. I have a question for you guys. What do you have in mind when we say maintenance? Okay. What do you have in mind normally? Give me a second. Okay, what do you have in mind when we said maintenance? People, you might think of repairing,
Upgrading,
boring job.
updating,
Sorry.
upgrading or updating.
Yeah, upgrading and what I mean, what do you think of? How do you picture maintenance job? Is that glamour job? Is that, you see, easy?
In my experience, it's not easy.
Yes,
It's
good.
not easy.
Maintenance is seen as not easy. Good. Even actually, most of the time, maintenance having kind of negative image. You know what I mean? People might think maintenance as a kind of what do you call underdog jobs. If you got what I mean. Yeah. So now look, this is some of them. Okay. Even that is my own experience. Okay. Funding for research is essentially non-existent. It is hard to get research fund for maintenance. This is based on my experience before. Whenever um, I propose a research proposal where I want to create a kind of tool for software maintenance. You know what comment that I got from ministry? Why do we need a tool? Okay, to fix another tool. Why do we need a tool to fix another tool? Come on, I said even maintaining a car, we need tools to maintain a car. Yeah, so something like that. And then and then what else? Yeah, maintenance is always seen as what do you call bad job. Is hard, is difficult, and most of the programmer try to avoid this kind of job. And look, another negative side. There is no common agreement in the industry about when maintenance begin or when it's end. While most of believe begin after deployment, but actually, in the right practice, maintenance start from the first day when we develop the software. We're supposed to start. We're supposed to begin with the ending in mind. You know what I mean? Started to begin with ending in mind. So this is basically software maintenance. Maintenance is thought to be a less professional job. Yeah, this is normal. Okay, by many view as a dead end, no personal growth path, non-creative works. Yeah, because lots of people out there they never claim they're actually maintaining something, but instead of why I'm proudly mention that I'm developing this, I'm creating this instead of I maintain this. Okay, we move. Um, so what is software maintenance? Yeah, I think we have been discussed this before. Um, anyhow, yeah, because lack of consistent definition something cause misunderstanding. Okay, what's the maintenance purpose? When does it begin? When does it end? What are maintenance tasks? Okay, who perform maintenance? Who pays for maintenance? So look, so it's the common maintenance definition. You can read this here. You can read them. It's all, however, it is. Yeah, it's all maintaining the same theme. It's about entertaining change. Yeah. First look, change made to computer program after they have been delivered. Okay, the performance of the activity required to keep a software system operational and responsive. To keep system operational and responsive. Process of being responsive to users' need. To ensure the application program remain in satisfactory. So all of this maintain, as I said before, is having the same theme, entertaining change. Yeah. And why change happen? Yeah. And this is some more definition, IEEE, the one that I discussed during our last sessions. And this is from ISO. So all of this maintaining the same theme is all about change. Okay, why software has to change? That is another question. Yeah. I will discuss that later in the following slide. But as for now, this one, and there are some maintenance terminology that you must be get familiar with. Okay, we have maintainability, the ease with which maintenance can be carried out. Maintenance, okay, the aim of keeping existing state of repair efficiency, validity, preserve. Who says something there in chat room? Yeah, protect. Good. Okay, evolutions. Okay, software is evolve. Okay, now so means that whenever software is changed, it's also evolve. You know what is evolve? You watch X-Men, is it? Yeah, the theory of evolution saying that we humans started from an apes. It's not me. I'm not an ape. Any of you? I don't think so. But that's the theory saying evolution. So even according to the movie, it is said that at one stage, because the evolution still happened, at one stage humans started to grow special ability because we evolve and we having some. Sorry, transform. Yeah, some of you my growing claws. The who's the guy? Who's the guy that having claws from Wolverine? Yes. So that's the story of evolution. So now for software also by nature is evolve. Okay, and how this evolution might happen to software? Do you have any idea? How software might evolve?
Adapt to the new technology.
Yeah. Okay, adapt to the new technology. Good. Of course, yeah, that one is good answer. Adapt to the new technology, and the other one, even let's say for any request of change, okay, it somehow will change the software at least in terms of the more lines of source code because of the new request. So software is expanding. The size of source code is expanding. And even sometimes we programmers might even create new class, new component. So this is how software is evolved. So the evolutions comes with the change of complexity. Okay. Now I bring you another idea of what we call as software aging. Even software is getting older and older. This is what is kind of funny in software maintenance. The more we maintain the software, okay, the more faster the software will get software aging. You understand me? Why? Because every time when you fix the software, the complexity is increased, the lines of code is increased, okay, and it just become harder to maintain in future if we not properly maintain them. Okay, so that's why the situation, the condition of hard to maintain in future is considered as software aging. Software getting older is hard to maintain. Imagine if I can use analogy of a human. Of course, old people is hard to it's hard to what do you call it's hard to cure them if they are sick. Is for old people is they are a bit delay in getting cured. Why? Because it's by nature is that way. Yeah, even though we have the same medicine but applied to younger people and older people will react a bit slower rate. So that's basically the software. The more we maintain, if we don't properly maintain them, the complexity of the software is getting increased and the software is getting more aging. Okay, so this is some of the terminology. Okay, even from the terminology itself, somehow I can cover the discussion just now about this is my covering half of this chapter already. Okay, maintenance from various perspective. Okay, we have various perspective of for software maintenance. Okay, we have the bug fixing view, the need to adapt view, the user support view. Look, okay, this is the most popular bug fixing view. I think this one is one of the most acceptable or familiar by laymen, by public people. Maintenance is the detection and correction of error. Okay, while for the need of to adapt view, maintenance is making to adapt, okay, with the operational environment, okay, or original requirement changes. Okay, the need to adapt view. And the user support view maintenance is to provision of to support the user. This is somehow might be related to this one. Okay, now look, even from this view itself, can you see that software maintenance, if we don't properly what do you call it, we don't properly manage, we don't properly control, okay, we end up with never end maintenance job. Come on, original requirement changes. This one, yeah, requirement is changed. Okay, today our client might say, come on, you just develop me something so that I can do this work and this work. Tomorrow when we submit the first versions, they might start saying that is that better if you can give me this one and this one, because they got more and more ideas, and because they got lots of recommendation would be from industry, because they started to have hints to feels to use the software. So if we don't properly manage this, how can we say that come on, what you request is actually new features instead of fixing whatever we agreed to develop before. Otherwise, you might end up what you call developing or evolve the software for free. Like, okay, so there are some crucial things about software maintenance. And this is just a common theme among definition, is that is after the fact activity. After, you know what is after the fact? After something happened, after the installations, yeah, after we got problems, after the new change, new updates in the environment, new updates in the technology. So this is what I mean by after the facts. So software maintenance is seen as a ripple effect of something else. Okay, since we're going to maintain, what we're going to maintain is software, there's also discussion about software. Okay, we have two different what is software. I know you guys know what is software. Okay, but while most of people believe software is only the final apps or the source code, but actually, okay, software is more than that. Software is include, okay, this one. Software is also include documentations, analysis specification, design system and user manual, and the procedure used to set up and operate the software system. Okay, software is actually consists of everything. What we call what we call this we call this as the artifact. Okay, software is actually comprised of all artifact in software development. You know what is artifact? Okay, we have source code, you have documentations. Okay, so look, example, during development, okay, we have all of these. We have a system test plan, we have system specification, interface control document, interface requirements, specification SRS, SDD, and everything. So all of these, okay, become product specification and become database description, because this will be document that we're going to use during maintenance. This is very useful. This is as our reference, because let's say if your customer requesting something, some new changes, we can refer back to this product specification. Is that included in the original specification or not? If it is included, then we should do something. If not, then we might suggest new proposal. Yeah. So this is to differentiate between new job and the fixing previous job. And we also have another documentation, okay, that's come with the completed product. Normally we have installation manual, facilities manual, user manual, software maintenance manual. So this is also become our reference during software maintenance, and all of these included in our maintenance plan. Okay. Okay, and what is application? Yeah. Again, we have various type of applications, from business to game. Okay. Okay. But then, okay. So each of this application has different behavior, and might have different, even the way how we develop them is different. If you still remember your software engineering subject, okay, for example, some type of application require prototyping. Some type of application we can do as simple as waterfall. Some of them okay, big software, big application, big project, my preferable using waterfall. For big for small and medium application, my more preferable with agile. Okay, and of course each of type of this application will require a bit different maintenance approach, a bit difference. Okay, um, but then because each of these has its own different constraint. Okay, one of the constraint, it's not really constraint, one of the characteristic, look. Okay, we return back to the definition of system. If you're taking computer organization with me, what was the definition of system? None of you taking computer organization, is it? With me before? Of course not. Have you taken? Yeah. But have you taken subject
right?
computer organization?
Yes, yes, doctor.
Yes, doctor, yes.
Okay. What's the definition of system?
System is like something work by computer to do specific job. It's not very clear.
Only computer. Only computer. How
System,
about
no,
how about your body system?
Yeah, exactly. That's right.
How about your body system?
Group of regulations or rules.
Okay, out of 10, I give you 2 marks.
A component or a collection of component to complete the task.
Okay, good. Yes. Basically, in any subject, in any engineering subject, if we discuss definition of system, it's always the same. What is system? System is basically a collaboration between component, between parts, various parts, okay, to achieve the same goal. Yeah. So, for example, system body, we have what? Your hands, your feet, your lung, your heart, everything, but and your brain. But they're actually collaborative, okay, towards achieving the same goal. Your goal might be one you want to move from one point A to point B, and your minds and your feet, your hands, everything is coordinated, synchronized to do that. So this is a system. So like was computer, we have RAM, we have processor, we have everything. Okay, computer system. But for a software, look, software is not actually only the application. Okay, for software, what means by a system? Look, we have all of this. Okay, we have, of course, the software itself, the documentation, transportations, communications, hardware, people. So all of this is a system. So imagine in software maintenance, we have to consider all of this. Yeah, even though yes, we might fixing the source code, but we need to understand the user, for example. Yeah. Okay, and okay, and this is also another aspect of system. Okay, system actually has certain hierarchy. Okay, for example, we have corporate computing system, and it's divided into several types. We have financial, HR, IT system, business system, this and that, and then another hierarchy, payroll. Okay, so we have how many? At least 1, 2, 3, 4. Okay, so maintenance is performed at all level. So this is another challenge of software maintenance. While you might think that software maintenance only fixing codes, but actually no, we also have to consider. Okay, I still remember when I was working last time. For a month, I might have to spend 2 weeks in Cameron Highland because we got client there in Cameron Highland. Okay, well actually the job can be done remotely from my office in Bangsa, but we still have to go there. Why? Because we need to understand the whole system. We need to understand the people. We need to understand to check the documentations. Okay, and then we can fix them. Yeah. So likewise, and this is also explained here because we have various type of what you call level. Yeah. So we need to work in all level. For example, let's say you need to fix payroll cost accounting. payroll cost system. Of course, you need to check the higher level, which is financial system. How this actually related with this, and what's other thing that might affecting this. Okay. Second, you might want to see stakeholders. I guess stakeholders would be the boss of the client, would be the account manager, something. Okay. Okay. So yeah, and I said about stakeholders just now. So who is stakeholders? Basically, stakeholders is any person or organization that has influence in the construction of the system. Okay, it's not only user and developer, but as well as look, owners, investor, customer, anyone. Okay, anyone that have influence. Okay, either during development or as the user of the application. So these are stakeholders, and operation maintenance in the software maintenance, we need to consider all of them, even including maintenance. Maintenance is also stakeholders of the system. Okay, any questions so far? Another 20 minutes to go. So who perform maintenance? Okay, a variety of different organization. Okay, would be software system developers, would be the developer itself, the developer who develop the software, maintain the software. Okay, and sometimes, okay, in a software house, software company, they we might also have special team only to do maintenance. I see some companies also doing this. Yeah, and most of the time these teams might consist of quite a number of internship students. I don't know why. Okay, first options, the same developer who developed the system also become maintenance, and sometimes second is the specialized maintenance group for that particular maintenance. They're not doing development but only doing maintenance. And it's my as well independent contractors. There are some third party company that only doing maintenance. I also seen this kind of company. Yeah, last time we used to send your senior, I think, doing internship in one of these company, independent contractors who only doing maintenance. Okay, and sometimes maintenance is done by user groups. Okay, do you know open source software? First, open source software. Okay, in open source software, uh, open source software is basically developed by public. Okay, so means that if you're a good developer, for example, you might have an idea to develop a system. You put the idea on the internet, you develop the first versions, you're inviting people from all over the world to enhance that. So this is what happened in Mozilla. Okay, Mozilla, what do you call, browser? Is that, do you know the history of Mozilla, class?
Don't know.
No.
Okay, have you ever heard about Netscape?
Yes, yes.
Do you know that Mozilla comes from Netscape?
No.
Okay, now I tell you. Okay, it's long history. Okay, last time, before we have Mozilla, we have Netscape Navigator. Okay, and during that time, this time during the early age when we started to have a graphic browser. Okay, before graphic browser, I think you're not born yet that time. To surf internet, we only have a kind of black and white screen. It's like you know, Unix or DOS command, black and white screen, and you need to know the command specific instruction to use internet, even to browse newspaper, for example. And during that time, I think only computer science students only using internet in the university. Yeah. Only, and in short, we might say only geeks use internet that time. Only geeks like us. And then when we start to have a graphical navigator, okay, one of the leading company at that time is Netscape Navigator. Netscape. And Navigator or browser at that time is actually sold separately. Okay, it's sold separately. We have to buy as we buy Microsoft Office. Okay, and then what happened was Microsoft, Bill Gates, somehow giving free browser together with their new Windows version that time. I'm forgotten what version of Windows. Okay. Yeah, Windows. The first, yeah, not Windows 3.1, with the Windows 95, I guess. Yes, 95, 97. So Netscape see that as a what do you call, as a try to kill their business. Because come on, I'm selling something. Now suddenly you guys created similar thing, similar product with me, and you guys give it for free. So what happened was Netscape, in short, Netscape finally what do you call it, sue Microsoft in courts. Okay, and you know what happened after that? Yeah, with the fact, okay, sue in court with the act of anti, was the act in business, what they call it, anti-monopoly something. Okay, but somehow I think Netscape for some reason lost, yeah, the case. So with that frustrations, because at the same time there are movement from open source community. Okay, the movement was started by, do you know who's the guy who started the movement of open source? Khaironi Item Sharif. Of course not. Is started by Stallman, if I'm not mistaken the name. Okay, so when Netscape heard about that movement, so Netscape, because okay, but before that, the open source idea was saying that software is supposed to be free, okay, and then we can make better software. So when Netscape heard about that idea, so as a kind of challenge to this open source community, he said, then Netscape said, now I give you the whole source code of Netscape, okay, with your idea. If this is kind of challenge for you, okay, prove that concepts. So then we end up Netscape in, I think, in very short time, within several days, become so powerful browser, and they call it Mozilla because it's getting huge. Okay, it's getting huge. So Mozilla is even until today is still considered as the most stable browser until now, and it's free. So that's the, okay, that's the, so in open source setting, okay, look, this is what is meant by users doing maintenance, because in open source, users can convert into developer somehow, because developer itself is a user. Okay, so this is why some users become doing maintenance. Even this is later, the same idea is later adapted by paid software, by non-open source software, when they actually training user to do some simple maintenance job. Okay. Look, last point, software maintenance engineer range in experience from none to a career of experience in a single system. Yeah, some engineers are very experienced. Some of them got no experience at all. But that's why we need what? That's why we need all of this. Oh, come on, this one, all this document. But somehow, in according to research in software industry nowadays, most of people, okay, neglect documentation is not a popular task in software development, while we actually need documentation in software maintenance. Okay, what's time now? Oh, another 6 minutes. Never mind, another 15 minutes anyway, if we, because just now we started late because of waiting for you guys. Yeah. Okay, so what's the difference between software maintenance and software development? Okay, look. In software development, we start from scratch. Okay, this what I mean by clean slates. We start from zero, nothing's on the ground. So we get the requirement, we do design, we do implementation, we do testing. So when we start from zero, obviously it's easier rather than maintenance, because in maintenance, we start with something. Even most of the time we start with problem. We start with the completed software that require us to understand the software. We require us to understand the source code in order to fix problem. So in software maintenance, look, we have parameters and constraint of an existing system. This is what I said just now. Okay. Okay, another difference. So in software development, system not in use. Okay, of course it's under development. So it means that no user. So whatever you do is not affecting user. While for software maintenance, okay, system are actually in use, and some of the user are trained users. So it means that they have experience in use that system. They have what you call as user model of the system. Let's say if we change something, we might get complaint from this user. Easily get complaint if we change something new which is out of their experience. So this is one of the challenge. Okay. Okay. In software development, another difference. Okay. Okay. Large scale functionality change because we start from zero. We are still developing it. Okay. So there will be large scale of functionality change. It's changing. Okay. Okay. While in software maintenance, okay, we have to make sure, okay, no functionality change, and when it's happened only moderate changes, because we can't allow large scale of functionality change. If we allow them as if we develop new software, okay, of course we don't want to develop new software for our client for free. Is it? They need to pay somehow, isn't it? Okay, so this is the difference between software maintenance and software development. And of course maintenance technical constraint. I think this one is straightforward, very understood. Okay, we have several type of software is mentioned here. We have open executions, embedded system, okay, development support, business system, scientific manufacturing system, and each of the system has different environment, different platform, different language, different external interface, different databases. So this becomes constraint in software development, sorry, in software maintenance, because we need to understand all of these before we can do anything. So that's why in software maintenance, according to research, this is actually one of my PhD thesis last time. 90% of maintenance job is trying to figure out of this. Only 10% is finally become something that physicalize, some things that we do in codes, okay, that finally affecting final product. So 90% was investigations. So if we can improve on these parts, okay, on getting this information for software maintenance, so it means that we can improve software maintenance. And remember, because software maintenance is considered the biggest cycle, sorry, the biggest portion of SDLC, software development life cycle, sorry. So improvement in software maintenance is actually big contribution to software development. Okay. So now look. Okay, this is how we supposed to do maintenance. While most of people believe maintenance only happen here, yeah. This is waterfall model. We have concept, we have planning, concept, planning, analysis, design, and then implementations, and then testing. Yeah, testing. Most of people believe maintenance is here. Yeah, well, actually, we're supposed to start maintenance from, as I said just now, from the very moment we decide to develop the software, even from the concept. Concept is a proposal. So during the requirement, we're supposed to think about maintenance already. Okay, and look, even this one, look, even during design, some of the system might do what you call as decomposition when we create software subsystem. Yeah, when we create a system subsystem. So subsystem might consist of software, hardware, and would be other subsystems such as what? Such as networking and so on. Look, and each of the subsystem has its own another round of this concept, requirement, design, implementation, test. Okay, so we even have to consider maintenance for each of these. Look, so that's why maintenance is basically the biggest portion of SDLC, because it's actually embedded together with another stage as well. And before finally phase out. Phase out is the moment when we decide the software is no more under maintenance scope. So you just phase out. We call it as a legacy system. Yeah, there are discussion about this later on in the following chapters. Okay, so why maintenance is needed? Yeah, I think this is also very straightforward. To provide continuity of services, okay, to make sure the system is keep running. To support mandatory upgrades. Example, government regulation. I think you still remember the moment when government changed our tax system. Okay, from what was the tax system last time? SST, and then change into GST. So what happened to the system that time? A lot of system has to change. I mean the business system out there, outlet system. Then we need to change. We need to upgrade the system so then to cope with the new GST. And suddenly when government change, they change back into SST system again. Our system has to change with that. So that's an example of this one to support mandatory upgrade. And of course, maintenance is done to support user requests for improvement. I think this one is very straightforward. You can understand this. You have been discussed this for several times. To facilitate future maintenance work, yes, some good software. Okay, that's why I said we started to think about maintenance the moment we decided to develop the software. So to facilitate future maintenance works, okay, we're supposed to provide features so that the software is ready to maintain. So means that the way how we create classes, the way how we create documentation, everything, supposed to be in certain disciplines so then it can be maintainable. And that's why in software development concept for documentation, for example, we have a concept called traceable. I'm going to teach you this later on in the following chapters. We have the concept of traceable. We have the concept of command software in your code, developing put command. Yeah. While most of students might think command is actually nothing because they got no syntax error, no nothing. But I say command is very important to have for software maintenance. Second, we have a concept of remember last time concept of high cohesion, low coupling. Yeah, means that loss of communication between component in the same class rather than out of class. I hope that you still remember that. Yeah, kind of this concept is actually to prepare software for future maintenance work. And then another one, maintenance is also needed because of redesign, database reconstructing. Let's say we have new database to cope with the what they call, to cope with the big size of data we hold. Okay, for example, so we need to database restructuring. So for that we need to do maintenance and even documentation updates. Okay. And this is most likely related to software re-engineering and software reverse engineering. Okay, I think this would be the last point before we finish today. Yeah. Yeah. Okay. The differences between hardware and software maintenance. Even though our focus is software maintenance, we need to understand about hardware software maintenance a bit as well. Hardware maintenance is administered in the three specific areas: preventive maintenance, mostly mechanical cleaning and adjustment of consumable replacement. And one is preventive, your cars, cleaning and so on. Replacements of broken parts. Okay, include installing engineering change to correct defects. Okay, changing your car spare part, for example. And expansion of system capability or functionality. Okay. Upgrading the hardware. Okay, sometimes when we upgrade the software, we need to install new device, new tool. For example, change your car with the new engine, example. And sometimes the expansion might involve installing new software for that hardware. This one may be tied to software maintenance. So somehow, even in the hardware maintenance, might involve software maintenance. Okay. Well, for software maintenance, we have how many types? We have, I think this, we already explained this before. Okay. We have 4 kinds of software maintenance. We have corrective, adaptive, perfective, and preventive. Corrective is to fix things, of course. Adaptive to adapt with the new change of environment, new change of the technology. Perfective to enhance, okay, to enhance some result for example, and might be because of the new technology that we have. Example, last time we might have what you call slower processor, and now we have new processor, so we have to change something to the system, so then the new software can work with the new processor. Perfective. And preventive. Okay, preventive is a maintenance, okay, to avoid expected problem. Okay, example, I think you was born after the year 2000, is it? What year you was born, class?
1999.
99.
Okay, forgotten. Okay, still, but of course you don't understand about concept Y2K. Have you heard about Y2K?
No.
Not even cross the word. Is it Y2K? Y2K. Okay, anyhow. Okay, Y2K was a global problem in software industry last time. Okay, because before the year 2000, people tend to keep dates with only 2 digits for the year. Example, 31st August 1970. So they write 31. They type in 31 August 0897. Okay, that one is sounds good. Okay, sounds good. No problem at all. And even in most of the software at that time, whenever they key in dates, they remove the 19 parts. Okay, 19 parts. Only keep the last 2 digits for the year. Okay, because we thought that time, by doing that we actually save some space, memory space. Come on, during that time memory is so expensive. Yeah, most of the computer that time only have 2 gigs of hard disk. Now even your mobile phone has 1 terabyte. It's crazy. Okay, okay. So but then because of the 2 digit, okay, the problem happens. They're expecting there will be problem happen when the year change to the year 2000, because now you got me on that. The year before that they only record for 2 digit 9799, and when it's come to the year 2000, if they maintain the same system, they will only key in 00 back to 00. What will be the problem then? Okay, one of the problem would be in banking. Okay, example, today I might invest. Okay, I might put in my saving let's say 1,000 ringgit today, and today is actually 31st December or 1999. So in the system it's mentioned as 31st December and then 99. So what happened tomorrow morning? 1st January the year 2000 is become 100. So somehow with the calculation, because for period is for time is impossible to have a negative value. So the system might miscalculate them, even though for only one night investment, but the system might miscalculate as 99 years or 100 years. So of course, one of the industry that was scared during that time was banking industry, and another one is military. So by the year 1990, early of 1990, 1995, it actually was the year when I was first graduated. It's kind of good business for software industry at that time, when we have to update all of the software, okay, to cope with the new year 2000. So this is an example of preventive maintenance to prevent such problems. For military system, they're very scared of that, the Y2K at that time. So what happened if there are some miscalculation for missile system, for example? Yeah. Okay, any questions, class? Yeah, now it's almost 11. Any questions? So I think if not, I think we're done for today. We continue the rest in the next class. So see you on Monday, I guess, next week. Yeah. Okay, so we run out of time, so I don't want you to delay for you at the end of the class. So until we meet again, so thank you and bye for now. See you then.
Thank you, Doctor.
Thank you, Doctor.
See you then.
Thank you, Doctor.
Bye.
Thank you, Doctor.